Microgrids are small-scale power generation and distribution systems that include various distributed energy resources, so-called DERs, loads, and storage systems. They can operate autonomously or can be connected to the main grid. DERs can include a combination of renewable but volatile photovoltaics and wind turbines with a reliable, dispatchable, gas-powered Jenbacher CHP unit powered by various energy sources, including renewables such as biogas, renewable natural gas, and hydrogen. Excess electrical power is also stored in a local battery energy storage system, or BESS. All of these assets are controlled and orchestrated by an on-site Jenbacher microgrid controller for reliable operation in any condition. The microgrid controller acts as the brain of the microgrid and can integrate a wide selection of more than 100 DERs while ensuring high reliability, plant uptime, and economics. Now let's look at an example. Here we can see the microgrid providing electrical and thermal energy to a commercial and residential area over a 24-hour period. The levels of energy demand and energy production vary. This affects market prices for power supplied from the grid. When there is a high surplus of renewable energy, such as solar and wind power, the feed-in tariffs are low, presenting energy arbitrage opportunities. It's early in the morning. Grid energy prices are high, so the local CHP system covers the energy demand of the microgrid, while surplus renewable energy that is stored in the BESS is exported to the grid to generate revenue. When the CHP system is running, thermal energy is stored until heat is needed in the district. As the sun rises, solar energy production ramps up, energy prices decline, and the CHP system shuts down. Local solar energy and cheap energy from the grid are used to cover the energy demand of the microgrid, while also charging the BESS for later use. Later in the day, as the sun sets, power prices increase. Due to higher winds, additional wind power is produced, but it is not enough to cover the microgrid's total energy demand. Therefore, the dispatchable CHP system kicks in to provide the remaining energy required. With the microgrid's power requirements met by the wind and CHP, it can once again export the stored surplus in the BESS and any renewable energy to capitalize on high feed-in tariffs. Later that week, the weather worsens, and eventually, a severe thunderstorm develops. Lightning strikes a nearby power line. Leading to grid outage. Within milliseconds, the microgrid controller enters island mode operation. It detects the grid failure, opens the main breaker, and transitions to the BESS while ramping up the CHP. Because of the super-fast response of the BESS and the inertia of the CHP unit, this switch happens with minimal frequency and voltage deviations. Thanks to the seamless transition, microgrid operations continue without any noticeable disruptions. Eventually, the grid failure is resolved, and the microgrid reconnects and synchronizes back to the main grid. The microgrid is now back in grid parallel mode. Jenbacher Microgrid solution offers both sustainability and resilience, peace of mind in one single solution. With Innio Group's MyPlant optimization, you can boost your microgrid's economic performance by enhancing operational efficiency and profitability. This energy management solution integrates external data sources, such as weather forecasts, market prices, and regulatory guidelines to predict and optimize the microgrid's operation. Together with MyPlant optimization, the Jenbacher Microgrid solution helps you meet sustainability targets and ensure high resilience and improved economics for your microgrid.